I'm Davis Bennett. I'm a independent software developer, but I do a lot of stuff with Zarr. I actually used to work more in bioimaging, where I also made a X-ray DASC resampling for multi-scale pyramids library that's still out there. I haven't used it in a while, but I think it still works. And I'm going to talk about type-safe Zarr APIs with Pydantic-Zarr. Um, and so we work with Zarr data like where it often has a structure. And what I mean by that is somewhere in the work you're doing with Zarr data, you might come across a sentence like a data set or whatever noun you prefer is a Zarr group with some attributes that satisfy constraints X, and then members like eraser groups satisfying some constraints Y. And this is a recursive definition because we have Zarr groups that contain other Zarr groups, and they might have structures at different levels. But this is like a reality of working with data and giving data to other people that you have some idea of like rules for the layout of your Zarr data. I think that's pretty common. But we don't really have good tools for modeling that. What we do have is like conventions that are embodied in the behavior of programs. Like X-ray has a convention of writing out Zarr metadata in a certain way, but that's a procedure. And I think it's nice if we have actual pieces of things of like entities in our software that can model this structure. And I think types are pretty good at that. So if we can express the constraints X and Y and all the other constraints of Zarr hierarchy in a language's type system, then we get some basically access to free, not free, but we get free access to nice software tools that can help us build type-safe APIs around Zarr data. And what I mean by like a type-safe API is an API that is based on the guarantees of the model that we have written down for the way the Zarr layout should work. And I'll show an example of that. So what would these types look like? And I mean types kind of in the sense that you can define a type for a JSON document, because that's fundamentally what Zarr is based on. And I'll just as a caveat, I'm totally ignoring the chunks here. This is purely a discussion of the structure of the arrays and the groups from the point of view of their metadata. The chunks is a separate concern. I don't think we're going to be applying any type checking to what's inside the chunks. So a Zarr array, and this abstracts over Zarv2 and Zarv3, but we can think of a Zarr array as basically a JSON document where we've got the array metadata that varies with Zarv2 and Zarv3, and then we've got the attributes. In Zarv2, the attributes weren't part of the array metadata document, which is why I have it as a separate key here. And the attributes are basically a JSON object where the keys are strings and the objects are other JSON objects. And then there's a group, and a group is basically group metadata, which is actually pretty thin. There's like Zarr format and then maybe consolidated metadata in there. And then there's the members key, and that's something that I am adding here because we want to model the structure of what's inside the group. Zarr groups themselves, like according to the spec, do not have a members attribute. But if we give them one, and then we give it the type string, and then the values are eraser group, so it's a recursive type, then we can start to model the stuff inside a Zarr group from a type perspective. And then the groups also have attributes, which is just going to be string to JSON. So I work with this with a library that I wrote a while ago, and it's called Pydantic-Zarr, and it has a very unimaginative title because I'm just combining Pydantic with Zarr. So you can think of it as like an alternate reality Zarr API that's much more focused on the Zarr metadata. So instead of an array, I have an array spec, and I use the name spec in there just to be really clear that this is not a Zarr array. Like you cannot write chunks to an array spec. An array spec is just a Pydantic model of Zarr array metadata. And so if you call here, I create an instance of an array spec, and this is for Zarv3. And this is kind of verbose because Zarv3 array metadata is kind of verbose. But we're making a model of an array with shape 10, data type, et cetera, attributes. And then we're printing out model dump. And this thing should be a valid Zarv3 metadata document that you could store, and you could put it on disk. And then you would, if you gave it the name Zarr.json, then you'd be able to read it in Zarr Python. So that's the array, and that's pretty simple, especially because we don't have to handle encoding and decoding chunks. We're just making a JSON document. And then for the group basically is just like the array in the sense that we can spit something out that has a structure similar to a group metadata document. But the group has the ability to take as a parameter members. And so here I'm declaring that the members is a dict with a key called array and a value that is the array that we defined before. And you see that when I dump this out, we get something that actually looks a little bit like consolidated metadata, where we have some information about our group. So I gave the group some attributes, so we see those in the output dict. But then we've got this sort of encoding of the tree, where we've got the members attribute, and members is a dict with a key called array, and these are all the array stuff, cell array stuff we saw before. And so if you look at the bottom of this example, you see that this group object has a to_Zarr method, and that will take a actual storage backend and some other parameters. And then you can actually write your Zarr group to disk. And it goes recursively. It writes all the members of the group. So you see that when we use the Zarr Python members method down here, we've picked up our array, which has shape 10 and data type uint8. We didn't write any chunks. So this is purely just writing JSON documents. And so because this is Pydantic, and because we've defined Zarr arrays and Zarr groups as Python classes with type annotations, we can ask Pydantic to check the types of the elements of the Zarr hierarchy. So here I'm going to import typedict to model a dictionary where there's a key that must be there and a type that we expect to be there. And then I'm also going to use Pydantic's base model to define a model of some Zarr attributes where we're opinionated about there being a key called foo, and it should have the value int. So then I define an array, which inherits from array spec, but I've overridden the type of attributes to say the attributes must be my adders. And then I've defined my members, which is a type dictionary, and that has a key that must be there. And the key is called required array, and it must be my array. And then my group has members that are my members, and so on. And so then I create an invalid array, and that's just going to be a regular array spec. And there's a convenience method to make these from NumPy arrays. And then there's the valid array, which has the right attributes, right? Because the arrays that are valid here must have attributes where there's a key foo and a value that's an int. And if I try and create an instance of my group where the wrong members, array invalid is a wrong, oh, Max has a hand up.
I'm giving you a 30-second warning.
Okay, then we get a failure. And so we've type checked the schema of this Zarr hierarchy, and Pydantic has said that doesn't match the expected type. And this is necessary for supporting solid APIs like this one, where we've defined the names of the elements in the members of our group, and we want to expose those elements as like properties to a consumer. We don't want them to know necessarily that they have to dig through that it's a subgroup or a subarray or whatever. We just want a Python object that has an array A attribute, and we leave finding it inside the hierarchy as an implementation detail. Because we model all this as types, we get that for free. And if something doesn't match what we expect, Pydantic will tell us when we try and deserialize. So that's it. Take a look at these two links if you're curious to know more. Thanks for your time.